Hi, this is Lab 2, Motion of a Falling Object, where we analyze the movement of an object at a non-constant velocity. Here is the video of our object in motion. And first, we outline some of the fundamental physics principles we'll be dealing with. The first of which is Newton's second law of motion, which is the net force equals mass times acceleration. We'll be using this equation in different contexts, however, because we have multiple forces that we're dealing with in this lab. And this also relates to the velocity update formula that we'll use, which is from the kinematic equations. We rewrite acceleration as force over mass. In addition, we are going to be dealing with a term called terminal velocity, which involves the drag force, and the weight force, which is the force of gravity. When an object is moving downwards, the force of gravity points to the downward direction, and the drag force points to the upwards direction. To create our models, we used glow script. Here we have our first wild condition, which is the time of the movement. For the first model, which only takes into consideration the force of gravity, we use negative mg, which is the mass of the ball times the gravitational force, which is 9.8. And we plug that into our velocity update formula. And we also update the position in the same way. For the second model, we incorporate the drag force, where we have a constant set which represents air resistance, and we plug it into our formula here that was outlined by the lab. And to calculate the new net force that will be plugged into our velocity update formula, we simply add up the force of gravity and the force of drag. When we plot all three of these values together, we see that the graph that incorporates drag better estimates our observed data. In terms of a model that predicts if terminal velocity will be reached, we can say that our model that incorporates drag predicts terminal velocity. As you can see here in the velocity graph, the model that incorporates drag starts to slowly level off more visibly than the one without drag. Terminal velocity is when the force of drag equals the force of gravity, so the net force would be 0, implying constant velocity. The question on whether or not the terminal velocity would change based on whether or not a ball was thrown is minute, because let's say, using glow script, we have an initial velocity that represents the ball being thrown. When we run the program, the graph is very similar to the graph that we created when there was no initial velocity. This is because terminal velocity is generally based on the actual object rather than the initial conditions of the movement. Possible sources of error for this assignment could have been the human error in positioning the center of mass in tracker, or releasing the ball of paper at a non-constant velocity, which would have skewed some of the acceleration results.